So far, we know that the analog signal is transformed into discrete data during the digitizing, which is performed by the A to D converter, and once this signal has been converted, it's available to the PLC processor. During the input reading section of the scan, the processor, as we know, reads the data value from the module and transfers the information to a specified location defined by you in the control program instruction. Let's look at it more closely. During the control of the process, a signal variable is measured by a sensor and passed to the input module. The module itself transforms the signal into a discrete value according to the resolution of the A to D converter. In this example, 12 bits. This value is placed in a holding register inside the module, which will transfer the value once the appropriate instruction is executed during the program scan evaluation of the latter control program. The instruction will transfer the numeric analog value into a register as specified by you in the analog input instruction used. This value is stored in the data table under a word location or register storage location defined by the instruction. This location can, of course, be accessed by other control instructions if necessary. The instructions used in PLCs that usually accomplish the reading of the analog inputs may be called, as we know, block transfer input instructions, analog in, block in, and it may have other names depending on the manufacturer. What's important to know is not so much the specific name of the instruction, but to understand how the data is being handled. If you know the syntax of the instruction, which is the way the instruction is represented and described in the program, and not the handling of it, you may encounter problems down the road. On the other hand, if you know the handling, the entering or understanding of the instruction itself will be very easy. Depending on the manufacturer, the address location of the module is generally defined by the physical location of the module within a rack or enclosure. A typical instruction will reference the address where the analog interface is located by specifying the rack or enclosure number, the slot or position where the module is inserted, the number of channels being used, and the starting address that will be used as a destination for storage of the analog counts. If 8 channels are used and the destination register starts at 1000, then the processor will store the analog counts for each channel in registers 1000 through 1007 octal. That is, of course, if the PLC we are using has the octal numbering system. You have to bear in mind that the processor takes care of the register range automatically. However, you must remember not to overlap the assigned registers with other instructions and to keep track of which register is holding which analog count value.